This video is on factor analysis. In this video, I'll discuss the theory of factor analysis. Make sure that you have gone through my video on regression analysis. It's important to learn a little bit of regression analysis before learning factor analysis. So what is factor analysis? Well, factor analysis is a variable reduction technique. Well, this is a technique, or these are group of techniques. In fact, there are a couple of techniques inside factor analysis. So these are group of techniques used to reduce the number of variables in our data set. And why do we need to reduce the number of variables? Often we are given a large number of variables for the modeling purpose, and we cannot of course use all the variables in our model. Hence we always want the best in class variables out of a whole bunch of variables, and factor analysis is one way in which we can reduce the number of variables. There are of course other ways, but factor analysis is one of the way. What happens is that when we are given a large number of variables for modeling, we often find that some of the variables are highly correlated, or there is redundancy in the data. Variables are quite related. Some the same variable is being measured twice, in a very similar fashion, but they are essentially giving us the same information. For example, you want to know somebody's ability in doing quantitative analysis. So how do you know somebody is able to do that or not? Okay, so look at the marks he has scored in mathematics, and you will know whether he's good in quantitative, whether his quantitative aptitude is good enough or not. Again, look at his marks in statistics or in computer science or in physics. So these all are quantitative subjects. So the most likely you will find that somebody who has scored good in physics will also score good in mathematics, computer science, statistics, because all the variables, all the four variables measure pretty much the same thing: the quantitative ability of a student. So naturally these variables will be related. We can we can say that there is a redundancy in the data set. So most of the times you will find that the variables you were given are redundant in nature. To get rid of this redundancy, we use factor analysis. So how do we get rid of the redundancy? Factor analysis reduces a set of variables, highly correlated variables, into a small number of latent factors. So what these latent factors are? Well, the latent factors are we call them unobservable variables. They are also a variable, but we assume that these latent factors are able to explain each and every correlated variables. Say for example, there are 5 correlated variables. They are correlated among themselves. Okay, and we say that okay, there are 2 factors which explain all these 5 variables. So instead of taking the 5 variables, we can take the 2 factors. Of course, we will study how to come up with these factors. It's not that easy. It's very difficult to understand, and a complex procedure is involved in order to find the 2 latent factors out of these 5 correlated variables. Okay, but only thing is that make sure that your variables are related in some way. They have a very high correlation among them. That's a precondition. Well, to give an example and to understand it better, well, our analysis for this particular illustration, I have taken it as how do we measure the academic ability of a student. Well, we can measure it basically by two means. Look at his quantitative ability and look at his verbal ability. Right? If you write GRE, we are also measured in these two aspects, right? One is a quantitative paper on quantitative things, and the other one is a paper uh, on the verbal side, right? We are judged in both aspects. Now quantitative ability can be judged by couple of indicators or couple of variables: mathematics score, computer programming score, physics score, statistics score, right? Now, verbal ability score, or verbal ability of a student can be measured by the score in the English or the verbal reasoning. That's how we measure the verbal ability. Now, say for example, we have been given this five variables, and we can be very sure that some of these variables are correlated. We have five variables: mathematics score, programming score, physics, English score, verbal reasoning score. These five variables are correlated among themselves in some way. Okay, mathematics score is correlated to computer programming score, and mathematics score again correlated with physics, and they're all correlated among themselves. But very unlikely mathematics score will be correlated to English, right? It may not be correlated. Okay. But English score will be correlated with verbal reasoning score. Okay. So if we are given these five variables, we need to find out which all are correlated among themselves and which all can be grouped together in a one factor. Okay. So if we are given five variables, we can get down to two factor or two latent variables. Okay. So quantitative ability and verbal ability, we can call it as a latent variable or a latent factor, whatever, factors are nothing but variable at the end of the day. So instead of using the five variables, we can just use the two latent variable in our model. We can only have quantitative ability and verbal ability. The question arises here is that how do we know that variables can be, which all variables can be grouped together, and how do we group them, how do we come up with numbers? That's a very important thing, and it's very as I said at the beginning, it's not a very simple thing to understand. But one thing is clear from here is that factor analysis is a technique in which we group similar variable into different buckets. Okay, so instead of using the variables, we just use the buckets or the factors in place. Right? That's the way we can reduce a number of variables. Say for example, we have 100 variables, we can get down to 8 or 10 or 15 factors, and then instead of using the 100 variables, we will be instead using the 10 factor, 10, 12, whatever it is. Of course, there are questions like who do choose the combination of variable, whether we choose the combination of variable, how do we group the variable, whether it's the analyst who does the selection or it's the computer algorithm. Okay, we'll see. Okay, as I said in the beginning that factor analysis is one way of exploring pattern in your data, right? Nowadays we have the concept of having very big data set or quite big data sets given to us, having lot of variables, and we don't know how to use them, and of course we cannot have this just all the variables in our model. Factor analysis is one way in which we can explore the data or explore pattern in the data to know which all variables are similar, and we can just drop some of them or probably group some of them into factors, all that thing. Okay, as I said, we have been given the 6-7 variables. Do I need to choose them, or do somebody else, or the algorithm will will tell me that which all variables out of these 6 variables on your screen you can see are similar. Well, there are two ways of doing it. You yourself can do it. If you are very good at knowing, you know the pattern in the variable, you know the pattern in the variable, okay, then you don't need to ask the algorithm in your software to do it for you. But if you have no idea about the variables, you have no idea how they are related, you don't come from the business, or you have no knowledge about the domain, or something you want to explore, something, probably you are quite an expert, you are a good expert in that area, but you still want to explore how the data or how the variables are related. We can use the mathematical algorithm to find it out, okay, and that's the two ways, like two ways we have in which we can select the similar variables and group it together. There are two ways of factor analysis, as I said. The first way, in which we only select the variables, we call it as confirmatory factor analysis. The other way is wherein the algorithm choose variables for us or finds out a pattern for us, is known as exploratory factor analysis. Okay, as I said, there are two different factor analysis available to us: exploratory factor analysis and confirmatory factor analysis. So what is exploratory factor analysis? Well, by using exploratory factor analysis, we explore the pattern among variables. We do not have any prior hypothesis to start with. We do not know which all variables are related. What is the pattern that exists in the data? We have no clue. Okay, we use mathematical algorithm to find it out. In confirmatory factor analysis, we only specify the model, or we only specify that this pattern exists. Well, the question that may be coming in your mind is that how do we know that? How do we know which variables are similar? Well, sometimes this is very popular in the psychometry and behavioral analysis, behavioral analytical modeling, wherein you have some idea from the previous studies, okay, because somebody might have done it previously and some idea is already there, or some knowledge is there, you have literature to follow. So, and somebody who is an expert in a particular field, say for example, I'm a businessman, I have been doing the same business for many years, so I have clear understanding about the variables. I know what exactly the pattern that exists. Okay, I don't trust the algorithm or the data. I only trust my understanding about the variable. So that is more like qualitative analysis. That's the way I group my variable. Okay, just by using my understanding about the data. But mostly we use both. Okay, they are used in conjunction with each other, because both the analysis are actually very useful. How do we know that both can be used? Well, in exploratory factor analysis, in short we call it as EFA. Using EFA we can get to know the pattern. Okay, we may be having some idea about the data, but we may find out some more information or some more pattern which we didn't know from the literature or from our existing knowledge, and then we can combine the both, the knowledge that we have got by using the algorithm in the data and the knowledge we already have about the data. We combine them both, and then we use the confirmatory factor analysis to make sure that our understanding, when we combine two kind of knowledge, is actually good enough for this data, and it's a good model, or as the word say, conformity. We confirmatory factor analysis in short is known as CFA. So EFA and CFA, it will be will be demonstrated in an example in the in a video wherein I'll use both EFA and CFA um, and do analysis using SAS. Well, the mathematics is not very simple, but it requires a lot of interest to go into the detail. But to keep it very simple, we assume that each variable, correlated variable, is a function of couple of factors. Okay, we have four variables: v1, v2, v3, v4. Okay, let's assume we have four variables. v1, v2 are correlated, and v3, v4 are correlated. v1 is a linear combination of f1 and f2. So is v2. So is v3 and v4. But if you can see, v1 and v2 are explained by factor 1. Okay, f1, because factor 1. So v1 is a linear combination of f1 and f2. Okay, it's like a regression equation. Okay, where the a1 is significant but b1 is not significant or very less significant. Okay, so we say that v1 is being explained by factor 1. Similarly, v2, the coefficient b2 is insignificant and a2 is actually significant. So we say that variable v2 is being explained by factor 1. Okay, and that's how we know that v1 and v2 are similar and they can be put together and we can just have one factor, factor 1. So in place of v1 and v2, we will use only the latent variable factor 1 or f1. Okay, how do we estimate a1, a2, f1, f2, b1, b2? Well, we estimate the factor or the values of the factor through the maximum likelihood estimation. To know more about the maximum likelihood estimation, please watch the video on maximum likelihood estimation. Similarly, a v3 is a linear combination of f1 and f2 again, but you can see the coefficient for f2 is significant here as I have marked, but coefficient of f1 is very less significant or not at all significant. Similarly, v4 is a linear combination of f1 and f2. The coefficient for f2 is significant, whereas coefficient for f1 is very less significant or not at all significant. And that's the way we group v3 and v2 and come up with the latent factor f2. Some of the uses of factor analysis, as I've already said, variable reduction is one use. When you have large collection of correlated variable, you can use factor analysis to come up with a very few latent factors. Pattern among variable. Okay, sometimes we need to know which all variables are very related to each other. So we can use it for exploratory data analysis before doing any modeling work. You are doing multiple regression, logistic regression, any kind of regression you are doing. It's good to run a factor analysis to know which all variables are correlated. Okay, so it helps in knowing your data or visualize your data or explore your data. When you have a lot of knowledge by exploring the data, you can build a model better. So it may not be directly used in the modeling, but yes, it helps in the model. Okay. And then the final use is the confirmatory modeling. Well, the confirmatory modeling is not a very popular modeling in the industry, but it's the type of modeling I'll not discuss in detail. There are different kind of confirmatory modeling available. One of the confirmatory model that I use is the structural equation modeling, wherein we define a model and then use factor analysis to confirm whether the defined model or the specified model is correct or not. you can explore on this more. I will not go into the detail. Certain things to consider when you are doing factor analysis. Of course, I'll be having another video on doing factor analysis using SAS, wherein all the things will be discussed in detail, and that will be a hands-on session, and will be you'll be able to make sense of the things better. Make sure the variables are related. So whenever you are giving variables to the algorithm, or inputting variables, the input variables should be related among themselves. If you know for sure that they are not related, there is no point in doing a factor analysis. Okay, you cannot have a completely different variables together and then you do some analysis on them. It's difficult. It's not recommended. You're simply wasting your time. You should have sufficient number of variables. Okay, so you cannot have a factor that is related to just one variable or a two variable. Okay, so that's not a very having a factor, one factor for one variable is unacceptable. Okay, at least three variables should be related among themselves or correlated among themselves, to so that at least one factor can be made out of the three variables. Okay, make sure you have large number of observations. Okay, because correlation is very unstable in case we have place number of observation. So more the number of observation we have, the better and the factor analysis can be done. One of the criteria, which is of course not a very strict criteria, is that variable should be multivariate normal. Well, what is multivariate normal? I'll have a video on multivariate normality, but to put it in this way, multivariate normal is the way in which all the variables you have used should be normally distributed. Multivariate means more than one variable, normal be normal distribution. So more than one variable normally distributed. When all your variables are normally distributed, naturally the entire data set is multivariate normal. Okay, but some researcher they say that the violation is okay. If there is a slight violation, then also it's okay. You can still use factor analysis. But of course, don't use purely categorical variables or dummy variables in factor analysis. Make sure that it should be continuous. Okay, or there should be some sort of a continuity in your data. How is it different from principal component analysis? Functionally they are same. Okay, we use PCA, or principal component analysis, and factor analysis for variable reduction and data exploration. So the uses are same, but the underlying assumption or the mathematics behind them are very different. Okay, there is a lot of difference between the two techniques. The details, of course, is covered in the PCA video. So once you have watched the video on principal component analysis, that's when at the end I have discussed the basic differences in terms of the mathematical estimation between exploratory factor analysis and the principal component analysis. Thank you.